All right, we're going to start with the next talk. I'd like to welcome Ricardo Garcia from Igalia, and he's going to talk about Vulkan CTS tips and tricks.
Okay, thank you. Thanks, everyone. Hello, I'm Ricardo from Igalia, and I'm going to talk about Vulkan CTS, give you some general information and some tips and tricks. So first, some bits about myself. I've been contributing to the Vulkan Conformance Test Suite since 2018. It's the same project that has OpenGL tests, but I have almost no contributions to the OpenGL part. I don't work on that. I'm not the only one at Igalia that works on CTS, and our work is on this front is being generously funded by Valve. So. As part of my job, I frequently interact with MISA contributors and people at Khronos. There's some overlap between both groups, especially in this room. So what is my job about? Is basically this. So the project is called VKGL CTS, and it's a Vulkan and OpenGL conformance test suite. Most people writing Vulkan drivers have had to deal with CTS at some point. It's open source. It's available on GitHub under the Apache 2 license. And you can see it has a lot of commits from many different contributors apart from us, but not much community or activity inside GitHub for reasons that I will explain later. And this is very common for Khronos projects. Right now, it has around 2.8 million Vulkan tests and 5 million lines of code specific to Vulkan. But when you run a test, you also use a lot of code from a common base that's shared with OpenGL. All right, to give you some specific details about the Vulkan tests, if you take a look at the top level README file in the project, it points you to a second README that's specific to Vulkan, and if you follow those quick instructions in that second README, you configure and build the project, and you end up with a binary called dqpvk in some subdirectory of the build directory. And that's the base binary that allows you to run Vulkan tests. You call it, you pass the -n option, and you indicate a test name, and it runs that test. And if you can also use asterisk in the name to form a a glob that allows you to run multiple tests that match the given pattern, right? So the program will print a summary of the results in the terminal, and put some a lot more detail about each test in a file called testresults.qpa. The tests are organized in a tree, with the leaves of that tree being the test cases that can be run, and the nodes leading to that leaf being the parent test groups that the tests are organized in. So one example is this. It's a Vulkan test that tries to see if copying between images with some given formats work. And at the start of the name, you can see the dqpvk, which is the root node, and there are subgroups to test the core API commands for copying and bleeding images, and a subset of those are run for all formats with different image types, like copying from 1D to 2D, using the general layout for both images. So that's what makes up the name of the test. So starting with the first tip is that if you dig deeper in the Vulkan CTS README, it mentions a few useful things. One of them is that when building the project normally, you build many more things than just dqpvk. You like stuff for Vulkan safety critical, some additional extra binaries, and of course, if you build calling CMake or Ninja or whatever, you can indicate that you only want to build dqpvk, but you can always create a shell alias or script or whatever to do that. But if you don't want to forget about it, there's a CMake configure option that you can use when building the project to specify the targets that you want to build by default, and that's called selected build targets. So you pass a list of targets, target names separated by spaces, and if you specify dqpvk only that binary will be built by default, which is much faster than building everything. Another configuration option that I find particularly useful is dqp log node source. This was added recently to main, so it's present in the most recent branches, main and some release branches, and requires a modern compiler to work. I'm told it doesn't work on all architectures, but basically, if you enable it, the log file will mention for every test case that is run where the test case is being added to the tree in the source code. This makes it way easier to locate the source code of a particular test. We'll talk a bit about that later. If you use this, there's a small performance penalty when creating the test tree in memory, but it's probably worth it in many cases. And for example, I always use this option when I build the DQPVK. Another thing is that the DQPVK binary is typically around 400 megabytes big in a debug build, and even more if you, depending on some other build options. So it takes a long time to link it. This is especially problematic when you're making changes to a single file and rebuilding, right? Many Linux distributions still use BFD or Gold as the default linkers, which are very slow for DQPVK. So my advice is to switch to LLD or Mold. And for example, in my previous laptop, the default linker took 30 seconds to link DQPVK. And with Mold, it went down to less than 2 seconds. Sometimes you can make them the default linker with update alternatives or stuff like that. And you can also set a link option from LD flags, and CMake will pick that up and configure the project. So moving on from build tips, I wanted to briefly explain how changes are reviewed and merged to the project. This is related to the community aspect that I mentioned before. So the thing is that every change that lands in the project needs to pass an internal review process inside Khronos. Who's reviewing and approving changes to CTS? Well, typically people who have a Vulkan implementation. That is basically a Vulkan driver running on some hardware, but well, software implementations also count, of course. And some reviewers work on MISA. For example, Samuel here reviews a lot of tests, a lot of changes to make sure they work on RADV. However, I think it's fair to say most reviewers do not really look at the source code for the changes. So they only want to check if the tests pass on their driver, and if they don't pass, they block the change until they fix the driver, if it's a driver bug, right? A change cannot be blocked forever in those cases. So typically the result is that changes are merged more or less quickly and all drivers work and are fixed at the same time. To help with that process, Khronos has an internal GitLab instance to track proposals for new tests and for issue reports and such. And if you don't have access to Khronos, you can report issues and submit PRs through GitHub, and someone will eventually review them and move them to the internal tracker. So again, if you have a Khronos account, go to GitLab. If you don't, use GitHub. If days or weeks pass and nobody replies on GitHub, feel free to mention us, especially if your issue comes from MISA. No guarantees, of course, but it may help move your issue forward. And you have some of our handles in the slide. So some basic stuff about reporting issues. First, please mention hardware, driver, and if possible, one specific case that is giving you trouble. You can also mention a larger set of tests if you think all of them are affected by the same problem, and things that can be reported. So obviously, test mistakes, especially if the problem is reported by the validation layers. Also lack of coverage if you think something needs to be tested. And a couple of tips about coverage. If you have just implemented something new in your Vulkan driver and all related tests seem to be passing, try to break something on purpose inside the driver and see if the tests still pass, because you may be surprised. And also, if you discover a bug in your driver that is quite simple, obvious, and it should be easy to reproduce, maybe it can be converted into a CTS test. So be on the lookout, think about that. So expanding on the topic of reporting issues, sometimes I get the feeling that people assume some minor pain point in CTS that they find, well, they are simply there, well, CTS is like that sometimes. So I wanted to mention more things that are fair game and are worth reporting. So configuration steps takes too long. Well, at some point, for example, a version of the validation layers was being built by default, and the dependencies of the layers were being downloaded during the configuration step instead of a previous step that fetched external dependencies. Issue report. Tests that take too long to run, maybe a pathological case of the shader being too slow to compile. This is happening, for example, through our Raspberry Pi team right now, and we are working on it, taking a look. Or the test is hammering the PCI Express bus due to choosing the wrong memory types. This was happening in MVK. We introduced a mechanism so that a test could easily select memory depending on the intention, what you're going to do with the memory from the host. And it solved the problem. We modified a few tests, and the runtime improved a lot. More stuff. Tests that take too long to skip or fail without giving you a hint about where, or without explaining why, neither in the terminal nor in the logs, or they don't log enough information, images, buffers, whatever, or the build time or link time worsens a lot, whatever. So it's not, you don't have to assume, well, CTS is like that. No, just please report bugs. It's interesting that we remove those pain points. So more stuff. Dealing with test failures. First, if the test logs an image to test results.qpa, you can view them with the Cherry tool that is mentioned in the README, but you can also use a self-contained viewer in the scripts subdirectory. It runs entirely in your browser. I have it as a local bookmark in Firefox, and you can take a look at the images and see what's wrong with them. Naturally, that viewer has some limitations. For example, images in the test log are logged as PNGs. So what happens with color depth when it's wider than 8-bit or 3D images, So ideally, this tool would be much more sophisticated. Images would be logged in a format that was more flexible, and the tool would allow you to examine layers of an image and raw values with precision, and maybe you could hover the mouse over a failing pixel and get a lot of detailed information about that. But the reality is that we don't have that yet. More things you can do. You can also run the test in RenderDoc. It should be easy. You should pass an option for that, as you can see in the slide. And finally, again, if the failure message does not mention a line and file in the source code where it's failing, which is trivial to log in CTS, please report an issue, because maybe we can change the error message so that it mentions exactly where it's failing, and you know exactly where to put your breakpoint to start investigating. In the meantime, the log no source option that I mentioned before can help locate the source code of the test. If you want to check what a test is doing, here are some hints about navigating the CTS source code. I don't want to talk too much about this, but some details are worth mentioning, should get you oriented a bit. If you log the node source and it points you to a line that mentions at function case something, you only need to check the functions that are being run. And otherwise, basically, the source code contains two things, which are test cases and test instances. Test cases are the leaf nodes of the test tree that we mentioned before, and have methods to check the requirements to run the test, to generate the shaders that will be used during the test, and another one to create a test instance. And the test instance is the object that runs the actual test. In a method called iterate, and internally they manage all the resources they need, images, buffers, command buffers, whatever. So the idea here is that test cases in the tree are kept alive since the start of the process until it finishes, while a test instance is short-lived. They are created when you run the test, they allocate the resources they need, they are destroyed after the test finishes, and they free all the resources, right? Well, the hard part is finding tests. If I was given a cent every time someone asks me if we have tests that meet a certain criteria, I could amass a small fortune. So we can always grab the source code searching for extension names, feature names, but things can get really, really complicated. Sometimes it's not only about feature X or format Y or a given API call. We want something specific about memory types and alignments, or in combination with some other feature or some other weird and specific requirements that may not be easy to meet. Sometimes we'll look at the source code and find that we do have that coverage. Some other times we have similar coverage, but not quite, and maybe easy or hard to add the requested coverage. And of course, sometimes we're lacking some general coverage and we need to create new tests. So, unfortunately, in many cases, the real answer is that we still need to rep the source code as we mentioned before. However, some of this is being changed nowadays, and we're making progress towards making the test requirements more explicit, in a sense, declarative almost. And ideally, at some point in the future, that should let us build a system that could be used to search for test cases, but by features, formats, etc. You can imagine something similar to such a Williams GPU info database, but for tests, and we can mix that with logging the node source and make it easy to find the source code of those tests that meet the specific requirements that you want. And that's it. Many thanks. Let me know if you have any questions, or maybe you also want to rant about CTS. If not now, maybe in the hallway, whatever.
First, thanks for letting us ask all of those questions. I'm guilty of that, for sure. But my question now is, sometimes we see that some things are tested on a specific queue, like let's say a graphics queue. Right. Is there any way to run the same tests but on the compute queue?
That is being worked on. There is a general, very old feature requirements for CTS to basically run every test that is possible on another queue that is available on the device, like in general. That's one thing. It's a hard problem given the state of the source code, but people are working on it right now, and eventually I think we will get there where we can run the tests, say, in the compute queue. Then that begs more questions, like for conformance purposes, do you have to run all the tests on all the queues exposed to the device to be conformant or not? So the answer is not simple. And then the other possible answer that we have been doing sometimes, as you know, is that we sometimes create variants, specific variants for some tests that we know are tricky to run on the compute queue or on the transfer queue or whatever, and we create variants of those for those specific queues. That is how we have been doing so far.
Thank you.
No problem.
Well, thanks for the talk. Are there lists for typically required packages for building the test suite for the common Linux distributions?
Sorry, can you repeat?
When building the test suite, right, you need build requirements like compiler and all that. Right. Is there a list of typically needed distribution packages you need for building?
I don't think there is currently a list of required packages, because in most Khronos projects that have to deal with some external dependencies, many of the dependencies are fetched before configuring the project. That's the approach that Khronos is taking, and it's up to people if they want to package the software to, configure the projects without depending on those external dependencies instead of using the operating system packages. But right now, the official mechanism is typically you run something, some script before configuring the project with CMake, and that fetches all the common external dependencies that you need. With those and a compiler, basically, you can always compile the software. That's it.
I think on my Fedora that didn't work out, and I reverse engineered, that was half a year ago, reverse engineered some of the dependencies. So at least it would be on my wish list, and a few of my colleagues I think did the same. So either we're doing it wrong, or?
I don't know. Sorry, I didn't get it, but we can talk more about that.
Maybe let's chat later.
Maybe I got your question wrong. Maybe
that's not a problem.
Yeah. We can talk about it later.
I have another far-fetched wish. Maybe we can parameterize the size of frame buffer in tests, like where it makes sense, or the size of copied images in copied tests, because for example, for turnip drivers, the size of the frame buffer is crucial for some things.
Yeah, I get your point. That is something that has come up in the past many times, especially for tilers, as you say. The driver may choose completely different code paths depending on the frame buffer. And I have the same kind of question sometimes when I am writing tests, because sometimes I'm writing something that is not directly related to the frame buffer, so I just choose a 1x1 pixel frame buffer because I am testing something that doesn't really require sophisticated things. But I know that ends up being a pain point for tilers because the code will be different. Yeah, that's an open question, hard one.
All right, we're at time. Thanks a lot, Ricardo.
Thank you.